All right. Thanks a lot for the kind introduction. Thanks a lot for all you guys still being here. This is great. I think we've seen a very good session. I'm pleased to be part of it. As said, now we're going to look into the process of annotating data, which is absolutely crucial for any applying machine learning on, for instance, images and point clouds. This is just a very short impression for you what data annotation actually looks like for point clouds. Does this move on? Oh, no, yeah, no. Well, this is just, as I said, a very short introduction for you how it looks like annotating data. It's a manual process, and it's, in most cases, polygonal selection of something, some object. And as you can figure, this leaves our kind guy annotating data not very happy. So what we need to do is, of course, avoid errors and double work in this. What motivated this work actually was some other boundaries, some other things that we faced in the project. First of all, we faced the situation that we had data of multimodality. So with RGB-D data and point clouds that were captured from the exact same object, same day, mostly within a few hours. So we need to ensure that we get consistent annotations, because as you might be familiar, RGB-D and point clouds are more or less the same, or from RGB-D images you can get point clouds. So from the same objects, these two point clouds being annotated from images and from the point cloud, slider point cloud itself should be the same. Then, of course, as you would imagine, these are different research groups involved and different annotators, so it cannot be based on the intuition and understanding of one person, plus we have computer science guys, plus civil engineers, and it's remarkable how the understanding of the building structure and topology is different. What we also saw was that, that existing data sets, except for there being not a lot of documentation on how the annotation was done, we think that they rather followed an intuitive approach on annotation. More or less it looks like this. So you look at the data, you see something, you then look into your set of classes and check, okay, is there something, for instance, window or wall? Okay, I'll use this class, if not, I'll add a class, carry on. This is, well, evolutionary approach, so in the end you end up with a set of classes and you may be limited by some list or something else that was given to you. Now, our approach is different with respect to two things. First of all, we decided to stick to the IFC ontology schema, whatever you will name it. Nevertheless, we just took the IFC classes and the descriptions that were there as a basis for our annotation rules. And then we defined rules and guidelines that would help the annotators to do their job thoroughly and without errors. And well, of course, these rules, you need to define them for images and point clouds. And that's, we'll not look into the rules in detail, of course, because you can look this up in our repository. This is just a very brief overview of the classes we did. It's about 50 classes at the moment, but we are still looking into it because the data set is going to be enlarged also towards construction site objects. And on that front, we will also add more classes. Nevertheless, yeah, just check the repository. I will now show you some examples and explain a few bits and pieces that we found that were particularly interesting when annotating data. So first of all, walls, well, generally they are from floor to the ceiling, but there are many, many other cases. And especially a thing that we saw and that we have as a rule is that some objects like windows, they should be related to a wall if possible. If not, this is going to be a problem for whatever you apply this data on, but it could be scanned BIM, for instance. So these are two examples of this one. Then the matter of doors. This is also interesting because in point clouds you have to incorporate the door leaf. and in most cases, even well, if it was from terrestrial laser scanning, then the doors would be open. And then it's a bit crucial that the guys find a separation line between the door and the wall. This is really not an easy task on point clouds. This is pretty hard. This is easier done on images, on image-based annotation. Nevertheless, on the image-based annotation, yeah, it can be tricky, or there can be some other difficulties, but it's what I'll show in a moment. Then for the columns, it's basically same matter. The point clouds can be tricky if there's no texture or if there's only a bad quality of the texture, because then you have a hard time finding the separation line of, for instance, of the columns to the other objects. This can be done a bit more easier in the columns. The columns we define as objects that always are from floor to ceiling, because you would, per definition, per IFC definition, columns are a structural object. That's why they would have to support something. If it's not, it would be, for instance, an invalid class or something else from the interior side. Then scaffolding. This is a class that leaves our image annotator very unhappy, because doing this on what you see on the right side is really a hell of a lot of work, because you have to select every single item, every single stud, every single handrail and whatever there is in scaffolding. This is a bit easier for the point cloud guy, because he can just select the volume essentially. Now, as I said, there is a particular problem with the doors. We have a lot of glass doors nowadays, because it's modern and also helpful for a light and open office space. And what you see on the left side is that we get actually a depth recall through the glass door. So there is something behind it. And that's why we can't follow the easy approach and just say, okay, we have a door. These pixels are going to be annotated as a door. That's it. That won't work, because there is data in behind, and when training a network, it could get confused why there is something behind the door, why there is data behind the door. That's why we actually annotate objects visible through translucent objects, through transparent objects, and add a flag that says, okay, this is an obscure, this is an occluded object, it's behind a glass pane. While the training algorithms on this is still work in progress, so we will see what effect it has. Nevertheless, it's an important point in the first point to get these differences right. And then for the RGB-D images, we have a lot of overexposure phase that was due to the sensor used. Nevertheless, all the rest is going to be an invalid class. On the left side, you see the point cloud from a building under construction with the lot of stuff hanging around and so on. So, what is this all good for? First of all, we are in the process of preparing this data set of more than 40 scenes. Some of them multimodal. We'll do instance segmentation for RGB-D. We will do semantic segmentation for the point clouds. There will be ground truth BIMs provided. And the main thing is increase the quality of the annotations. Have annotators do it the way you want it to, because if you have to explain it to 5 people, that's a bit of a pain. And get consistent annotations among different modalities. Now the hypothesis is that we increase quality and that we get consistent annotations. This is still to be evaluated and proven. First results are pretty promising, but in the end we have to see if this actually did the trick, or if we have to think of something entirely different. Then we would encourage everyone who is in this field to interact with us on this, maybe use the rules, or give a feedback to us that these were more or less useless and that we have to think of something else that's worthwhile as well. And we will finish and publish the data set. Of course, you will see this through publications. Now, last thing to say is this was a collaboration in a European project funded by the European Union. And the main collaboration was between me and Jason, who is a team leader at the Research Center for Artificial Intelligence at Kaiserslautern as well. Thanks for your attention. I'm happy to answer your questions.